BASF, you can see here that we create chemistry, and so we need environmental plants. And we actually have one at the plant, so I really enjoyed the presentation. Thanks for that. Kind of teed us up pretty well too. At BASF in Seneca, Tina and I are both from Seneca. We are a precious metals facility. We'll give you some background on that. Because this is going up on a public site, we're a large organization, so there's just a disclaimer slide. We'll just go past it. So I'm going to talk to you. Oh, that got cut off.
That's all right.
So I'm going to go through a little bit of my background, just so you can kind of get a feel. You heard Dr. Schlosson say it's not necessarily linear, and my career has not been a ladder either. It's been a matrix. And so I'll give you a little bit of kind of background. I'll turn it over to Tina and allow her to do that, and then we'll talk through the agenda. So I'm a South Carolinian native. I was born and raised here in Aiken. And just to tell you kind of my influence throughout my life, it was a guidance counselor in high school that delivered some tests, I don't even remember what it was, that kind of spit out the results of what was I going to be good at. And it told me engineering. I love science, I love math, and it said engineering. I had no clue what an engineer did. And I had a father that was an engineer, okay? So I spent a lot of time wandering. I had a high school chemistry teacher who took us on exploration with MUSC in Columbia. I thought I wanted to be an orthopedic surgeon. My mom was a nurse. She took me in. This was way before HIPAA. My mom took me in to see an orthopedic surgery done. I almost passed out, and I said, nope, that's not for me either. So it was really just walking through that. I decided to ask my dad what he did, to see if that was really what I should do. He set me up with a lunch date with two of his female engineers that worked for him, and I fell in love with the idea of fixing things, solving problems. So I went to Clemson in general engineering. Back at the time, I don't know if Clemson still does it, but back at the time they had a general engineering class that exposed you to every single discipline. Now, I'm dating myself here. I have a ceramic engineering degree from Clemson. They obviously don't have that specific degree anymore. But really engineering at Clemson, back when I was there, gave you a great opportunity because even though I was a ceramic discipline, I still had to take an electrical engineering class, and I still had to take some other classes that got me kind of exposed to really understand that this is what I was really passionate about and what I really wanted to do. So I graduated from Clemson. I started working with Owens Corning. I worked there for 15 years, then I moved to the American Red Cross, where I worked for about 6.5 years, and I now work for BASF. I am the Quality and Continuous Improvement Leader at BASF. So, just so you know, I think I probably used my ceramic engineering degree in about 20 years of my career for 2 of them, okay? But what Clemson taught me, what Clemson engineering taught me, was how to be a problem solver, how to take those critical thinking skills and apply them to whatever I was working on, which led me into the kind of the quality and continuous improvement pathway. I don't know if you guys have heard a lot about lean manufacturing and Six Sigma. Those are a lot of the big Fortune 500 companies are using those, their tool sets to really, it's a systematic way. He showed you the 5-step process. We have one too that's 5 steps that kind of follow that same thing. We just use a different acronym for them. And which has landed me here at BASF, applying those and working with people. So I'm going to let Tina introduce herself so you can learn a little bit more about her.
Okay. I have a BS in chemistry from Indiana University, which is in Pennsylvania, Erie, Pennsylvania. So very top of Pennsylvania. A lot of snow, 213 inches the year I left and came down to Seneca, South Carolina, so I was very happy to be down south. So that was good. And what started me into the chemistry, I tried the engineering, went, not for me, but was my chemistry teacher. No matter what I did in college, it was going to be because he was good at what he did. I loved his passion, so I knew it was going to stay in chemistry. So then, I started out very similar to you guys. After I said, one semester in engineering, I'm like, it took Fortran, I'm really dating myself now. I said, no, that's not going to work. So I went into chemistry with a minor in education. I went through all of my minor in education and my chemistry degree, and I got to my last year, my last portion before my student teaching, when I went off on my own and would become a high school teacher, just like y'all.
Yes.
And I went into a practical with an all-male private school, 11th and 12th graders. And I went, of course, 11th and 12th graders, you're going to try, you're going to do everything you possibly can to say, how am I going to mess with this one, right? Well, and they did. And I walked out of there after that, finished it, completed it. I was successful in what I was doing, at least so I thought, and I went, no more, not going to do that. So I finished my degree in chemistry and went on and got married, had children, and then went directly into the manufacturing world. So Erie is a, metropolitan area for manufacturing. Right now it's all for tourism. And, GE's up there, Hammermill Paper went on the wayside. So the only chemistry opportunity that we really had in Erie was BASF. And what I did was, when I realized that we needed 2 incomes, I said, I'm going to do this. And I went in as a temporary into the lab. And I thought, when I was in college and saw the high school and the interaction, I said, I want to be in a lab by myself researching, doing what I do best, and I'm the one who can control it, right? I did that for 1.5 years and said, no, can't do this either. So I actually went out on the plant floor full-time as an operator. So I started from the ground level. You have to have a high school education to get in and to be able to start your manufacturing career. So I spent 6 years in manufacturing in operations, and in that time I worked back in the lab, I worked in research and development, and I went into leadership and management in 2001. So I've been doing that ever since. Spent 18 years in Erie, and then transferred down here with a colleague of mine, and I've been here for 3 years and 3 months. So it's been a good journey. BASF has been good. And we'll talk about all the opportunities that a manufacturing community can bring. Math and science, even in high school, can be good to somebody at a floor level operations person in manufacturing. So it's not that we don't want to continually say we want you to continue with your higher education. We look at these kids who may not be motivated or know what they want to do with life and say we have the opportunities with the math and science that you've already taken to apply it with hands-on type opportunities. Okay?
So we're going to introduce BASF a little bit to you. You notice he had BASF on this slide, so it was neat to see that. We'll talk about the catalyst division. That's where we fall into at Seneca. Tina's going to share with you about our Seneca facility. We're going to talk about key performance indicators and the things that are important to us as a company and an organization. We want to talk to you a little bit about success in manufacturing. Tina will talk to you about opportunities, and then we'll let you have questions. So at BASF, chemistry is used in almost all industries. We combine our economic success, social responsibility, and environmental protection as part of what we do. That sustainability aspect that you've already heard about is very important to BASF as we look to the future of the globe. We have over 100,000 employees, and we have 6 Verbund sites, which basically just means many things. Shared resources happen on that site. And then we have 353 other production sites. So we have 5 segments. I'm going to show you those in just a second. With global and regional business units. We have strategic business units. We have regional things that happen. Basically, we're a global company, right? But we then have different leadership structures and those types of things depending on where you are in the globe. So these are our 5 global segments. We have the chemicals division, the performance products division, the functional materials and solutions. We have the agricultural solutions business, and then oil and gas. And so where we fit in Seneca is inside that functional materials and solutions. So let's just show you a little bit about the globe. So BASF, actually the global headquarters is in Europe. So about 57% of our sales are generated out of Europe. For North America, we have about 21%. I saw a map actually yesterday. We're predominantly in the East Coast, up and down the East Seaboard. So as far as where we are in North America. We've got some presence in South America, Africa, and the Middle East, and then also some presence in Asia Pacific. So with the catalyst division, remember this is where we fit. This is just kind of gives you a footprint of our BASF catalyst division from the different types of materials. I will walk through all of them for you. So let's learn, I'm going to pass this over to Tina so she can tell you a little bit more about the different things that the catalyst division does, and then she'll tell you about Seneca.
Okay. Does anybody know what BASF was first known for? Indigo blue dye. So the first blue jean dye came from BASF. So just a little tidbit of information. Okay, so the global emission catalyst. We are part of this. We supply the precious metal to CCE. So what we do is, we'll get into that, but we actually refine metal from garbage, from people's spent catalyst, from their teeth, from their trash. Anything that it comes from, the catalytic converters come in. So we have platinum and palladium on catalytic converters will come in and we'll crush them and we'll refine that metal. We'll get into that a little bit later. But we provide that metal back to the market so that they can apply that platinum back onto the catalytic converters and resell them. So emission controls, maybe what Volkswagen was, cutting off was actually another catalyst that we produce. It is a ZLA, along with the platinum that filters through that. So Volkswagen was actually just bypassing that whole stream of filtration for the air. So environmental, once again, we are creating the solution for the environmental, and other people are saying it's easier to bypass, which is a big issue in the environmental world. So chemical and the olefin catalysts and absorbents. That's really what we do at the site, along with the refining business. So with the chemical and the catalyst, what we do is we make the chemicals. We make the chemicals that we spray palladium on. So this stuff goes into this stuff. These catalysts, go into being able to absorb contaminants out of their waste streams. It could be that of course everybody in this room knows what a catalyst is. It heats up a chemical reaction so that the customer can make more of what they wouldn't have in the first place. I mean, it's just something that helps them and heats up their chemical reaction. So we spray palladium, platinum, gold, and rhodium onto carbons, onto silicas, onto aluminas, and they could be spheres, they could be exudates, it could be powder, it could be granular, all sorts of things. And we do this in a batch scale, so everything is like making a cake. It's the easiest thing to say, because when you go in there, you may have 50 different products running at once in the whole plant, but each person is doing their portion of the cake. So we can be making the cake over here, the batter, we hold it for a couple months, I know that would be bad. And then we move it to the oven over here. I know, so maybe not the best analogy, but then it just goes from portion to portion. And sometimes we're our own internal customers, and we'll be sending it off to another site to be, finish it off, or to spray it, or to calcine it, depending on their capability and what capabilities we don't have. The catalyst and additives for oil refining. This is making sure, have you ever heard of crackers? Oil crackers, steam crackers. That's what we provide the catalyst for. the current and the next generation battery materials. And the reason that you saw some growth in Asia is because it is surmised that maybe they're going to be getting more cars. I mean, people do a lot of biking, people do a lot of walking. So the smaller cars may be more economical for them in the near future. So we're building up the ability to be able to provide for that. Precious metal services, and what I was talking about before, we provide a full loop stream for that. So we bring in the trash and we hand the global trade market the platinum and palladium. And we get it, comes in possibly, sometimes 0.2%, and then we get it to 99.9% metal. Most of it we use back into our system because we consume so much of it for the emissions group. New business development, white spaces and ventures. We're always looking for places where we can be cleaner, more sustainable, where water streams may be a little different, that we can provide our own water rather than using utilities from another provided customer. So we're looking for people like we have places in Savannah, so we're next to the river. Very easy to provide the water for our business. So we're always looking for better, cheaper ways to do what we do best. Okay, so the Seneca facility, we're located in Oconee County. The plant started in 1986. So that was green space, we started it from scratch. We were acquired by BASF in June 2006. Prior to that, we were Engelhard. So it actually was built as an Engelhard facility and became BASF. We have a 93-acre site, and we're 332,000 square feet under one roof. We have expanded since then. We do have some outliers here and there. And we're approximately 330 full-time employees, or about 450 with contract work on staff on site. So the Seneca facility, it's a vital part of the catalyst division. We're actually one of the largest catalyst divisions, or sites out of the catalyst division. We're ISO 9000 certified, so everything that we do has to be documented, vetted, and approved. So we don't put a procedure out there that can't be put into have people go into an unsafe setting, or put their materials together where they might explode or exotherm or foam out of a unit. It's a 24/7 operation. We have the two businesses that I was talking about. One is the CCM and one is the CCP. CCP is the catalyst. CCM is the metal refining. So we have a pretty robust portfolio. We have the precious metal refining. From that, we make the precious metal salts and solutions. Most of our materials go out as salts and solutions if we do not apply it to our own catalyst. We do have a small minting operation, so that if we get to the point where we do have orders for pure precious metal, we can mint it and we can ship it. And water purification, our zeolites, is right now being used in Fukushima for the radiation cleanup as we speak. So that's very good. Okay, the precious metal. As I said, we do trade precious metal. And what we do is, you kind of get a small picture of it here, but it's more like, has anyone ever stared into a fire pit and just been like mesmerized? Well, that's what I do here, because this is some cool stuff. What we do is we take this garbage. Could be teeth, could be garbage, just trash, plates, could be anything. And we burn it, we mill it. And then what we do is we use our abilities in an electric arc furnace to take these temperatures up to 1700 degrees. We make molten metal out of this. And what it will do is it will actually stratify in layers. And there's seriously just a plug in this arc furnace. And we'll take that plug out, and the portion that we want to come out will come out. And then we'll dig that up, and we'll take it to another process, which we will actually make it to molten metal again, and we'll do the same process until we get it to about 20% precious metal. And all the other stuff, we just, send away to the landfill, unfortunately. But it came to us, so we have to get rid of it. And then what we'll do is we'll actually do so this is the pyro, and then we go to the hydrometallurgy, which is the wet prep, and we'll actually dissolve the metal that's at 20%, and we'll get all the impurities out of it. We'll do some precipitations because some things will precipitate to others, and we'll actually be able to filter it out to get it to a higher quality, and then we'll be able to sell it to the open market. And we also have our own dissolving unit where we'll provide the solutions, like I said, to catalytic converter businesses and whatnot, the low emissions. So we're really putting a focus on customers. And what we want to do is we want to, secure what we have coming in. So we're a business, we want to be, sustainable in the future. So we want to make sure that those customers are satisfied. We want to make sure that we have our resources focused on what we can do in the furnace and in grinding and panning. And these things we want to make sure we're working on right now is to do our optimization. And Lisa's going to be a good resource for us to be able to say, how are we going to do this better? How are we going to make the most use of our time? And then we're going to sample this and send it to the customer, give them what we believe is in, or what we have tested, not what we believe, what we've tested to be into their product. And we're going to have a resolution on the metal. And that's how we make our money. And then it goes back to the customer after we've done all of that process.
So what we wanted to talk to you a little bit is how we measure key performance in a manufacturing site. And I think this is important at the high school level, or even, I know some of you guys are from elementary schools too. It's so important to stress these in the classroom too, okay? At BASF, with the things that we do at the Seneca site, safety has got to be a priority because we want our employees to be safe. We want the community around us to be safe as well. And so one of the things that we wanted to share with you are how we measure our own key performance indicators and allow you the opportunity maybe to build those into your classrooms so that as folks come out, whether they go straight into manufacturing from high school or whether they go on for advanced degrees, they're starting to get a taste of what the world's going to be like. So we measure 5 key metrics. Our people, we have people that work at our facility, so it's important for us to have those people metrics. We have safety. Our environmental falls up under that. We call it EH&S, Environmental Health and Safety. Our quality systems, Tina talked to you about the customer. The customer determines, a lot about what we do, product specs, and those types of things. So without the customer and without that knowledge and that collaboration with the customer, we would struggle, especially if we're doing what we think is best and not necessarily what the customer feels is best. Delivery, our customers want it reliable and they want it accurate, So a lot of times we are a batch operation, so we're kind of a make-to-order type environment. And then cost. In the economic conditions that we're in today, doing it productively and doing it efficiently improves profit margin, which helps the business, the organization, but also helps our customers. So 2 key things. There's leadership on top of that, So not just developing the technical competency within your students, but also starting to enhance those leadership skills. And you've already heard it, problem solving, in this type of environment, we problem solve every day. And having good problem solving skills is key to our business. Okay, next one. So what do we consider success in manufacturing? Teamwork is huge, With the opportunity to work at various levels in the organization, whether you're dealing directly with a customer or whether you're working with process engineers to optimize the process, that teamwork and collaboration is so important. Communication. Communication is another key aspect of success in manufacturing because we have external communication that we have to do with our customers as well as suppliers Even down to at the site level, we have to communicate with our executives. And so it's really important that you understand how to communicate at various levels with various audiences. Technical competence, I think that's kind of a given, right? If you're working in an industry like ours that has a chemistry base, you've got to have that technical foundation. Leadership, we've already talked about, and then problem solving. So those are what we see as important. Now Tina's going to talk to you about what kind of opportunities we have at BASF with folks that have STEM type interests.
Yeah, I guess what BASF has offered me, and like I said, I've been in various different roles and positions in this company, is the opportunity to do whatever I felt I wanted to do and what I was good at and what I thought I was good at. I could try anything, be successful, be part of that team, and actually contribute. They're always willing to do that. And a lot of the manufacturing communities do the same thing. If you wanted to work in quality, which is where I started, so this is not all-inclusive of what you can do with BASF by any means. But that ladder can be a ladder, or that ladder could be a here and there, and it takes you maybe a little bit longer to get where you want to go. In manufacturing, it could be in manufacturing. You could be a leader in manufacturing. You could be on the floor. You could be in projects, which is at the bottom. Engineering, of course. Research and development. Management. Environmental health and safety. When you look at somebody who has a chemistry degree, such as myself, you go, okay, so where do you belong in the H&S community? I think somebody like BASF and a company like BASF provides those skills if that's where you want to go. So it's not like you're going to just be doing one thing for the rest of your life. Your opportunities are open. And when you're having conversations with your students, you definitely can say this if they're even thinking that a manufacturing community is where they want to start. Continuous improvement. If we don't continue to improve, we don't exist. If we don't get better and provide customers and services and the best services, somebody else is going to beat us out. And we will no longer have that customer. So that is a huge portion of what we do. Sales and customer service. You wouldn't think somebody like me or her could get into that, right? Yeah. With the BASF, they would provide the skills to help you attain that. Same thing with procurement. If you ever just want to order things, and I'm sure that they do way more than that, but this is on the news, nobody ever read it or see it, but you can do that. Accounting, the same thing. That math degree and the education that we came up with the engineering and chemistry provides us with a lot of math experience. And all of the skills that we're receiving from BASF as a whole is just compounding to be able to use those skills in any of these opportunities. So I think what we want to leave you with is companies with chemical engineers and chemists. They're not all inclusive, and you don't just do that for the rest of your life. You have opportunities to switch jobs. So if you don't like something, you have the education to be able to create your own environment. And this has really been important with me because I didn't know exactly what I wanted to do. I maybe still don't know exactly what I want to do. But, I'm in management now, and that's what I enjoy. But the opportunities are just abundant. So you have any questions regarding any of the slides or what we do at BASF or possibly the opportunities?